When the magma accumulates under the Svartsengi volcanic system in the Reykjanes Peninsula of Iceland, it rises the land, and we can measure this land rise by measuring the distance between the sensors we put on the ground and the satellites which are orbiting around the Earth in a geostationary positions. So practically we can measure this through triangulation, and what we find is that the amount of the land rise before every eruption has steadily increased, and we can see that also it takes longer time for the magma to accumulate than erupt. Each time is getting longer. This is the spreading of the mid-Atlantic ridge in the Iceland, which is extending, and through the cracks is created through the extension, we will have the magma able to rise and erupt as lava. This is the rising of the magma which creates this uplift. And when there is not a passage for it, or is very narrow for the magma to pass, the pressure is built up. And the Svartsengi volcanic system, which we think is responsible for this, has around 20 million cubic meters of the volume for that. It is now past that threshold. 60 megatons density of the basalt is 3. Basaltic magma is 3. So multiplied by 20, you will get 60 million megatons. But we don't see that eruption. If it doesn't erupt any moment now, it may be a reason to conclude that the magma source is coming from a bigger reservoir which has more than the 20 million cubic meters of magma capacity. And we know that by the analysis of the basaltic lava from these eruptions in the Svartsengi, that we are seeing two patterns, two groupings. And the one that erupted in the June and May 2024 are actually similar to what happened in the Fagradalsfjall. They're coming from a deeper source, 12 to 15 kilometers down in the earth ground. Every time these eruptions happens, we need earthquakes to actually soften up this, make it fluid, and make it able to flow. Earthquakes do this for us, like a ketchup when we shake it. So these earthquakes are able actually to make it fluid. We are not seeing that amount of the earthquakes still. And every time, with every eruption, the amount of the earthquakes from the initiation to the end takes longer. We don't have that amount of earthquakes, and at the same time, this is, for example, from Fagradalsfjall, nothing compared what we saw here in the Svartsengi so far. The latest IMO update shows that we have reached that threshold for the previous eruptions, which was 20 million cubic meters. We'll add to that IMO update that if it doesn't erupt any moment soon, it may mean that the source of the magma is deeper, is not a Svartsengi reservoir, is the deeper source, which is sitting on the top of the mountain, closer to the base of the Earth's crust. Of course, IMO has published also the hazard map. You can see that we expect eruption within the Greenland vehicle, so at least flow of the magma, which will be less dramatic, but more dangerous because we will not notice it easier. And what I'm telling to you now is that as the magma is a non-Newtonian fluid, we need more earthquakes to make this non-Newtonian fluid to actually be able to flow and reach the surface. We need bigger pressure. The pressure is not enough, although it is very extreme for the Svartsengi.